Students, today's topic is partitions and equivalence class. These two words are very allergic to students because this partitions and equivalence class is difficult to understand, and also in plus 2 exam there is no 4 marks or 6 marks questions. So students leave this, most of students leave this, because if it will come only 1 mark will come, and we have to invest a lot of brain in understanding partitions and equivalence class. So students leave this, but my request is don't leave a single mark also, and the topics are also not difficult, they are very easy. You have to understand the minute concepts present in it clearly. Once तुम कॉन्सेप्ट को ठीक रे धरदेल पार्टीशन्स एंड इक्विवेलेंस क्लास किसी कष्ट नुहे, तो आस आज तुम कॉन्सेप्ट्स केमिति धरिबो पार्टीशन्स एंड इक्विवेलेंस क्लास उपरे मु बुझौछि. सो बिफोर गोइंग टू द डेफिनेशन ऑफ पार्टीशन, लेट अस एक्सप्लेन यू with help of a diagram. Let this is a set A. This is a set A. Now I have taken this as set A1 and this as set A2 and this as set A3. Set A is splitted into 3 subsets A1, A2, A3. What we can observe? We can observe A1 is subset of A, also A2 is subset of A, also A3 is the subset of A. All 3 sets A1, A2, A3 we considered are subsets of A. Another important thing we can observe, that is A1, A2 and A3 are disjoint sets. Look at, there is nothing common in A1, A2, A3. Not a single element common in A1, A2, A3. Because common thile Venn diagram kemiti heitanda, emiti case re if this part A1 nebi, this part A2 nebi, तो A1 और A2 set भितरे these elements are coming common. But here look at, not a single element is common in between A1, A2 and A3. So we clearly say A1, A2, A3 are disjoint sets. Another character, look at A1 union A2 union A3 is equal to set A. If we make union of A1, A2 and A3, then we get set A. So these 3 conditions satisfy hele, we can say that A1, A2 and A3 are partitions of set A. What are the conditions? Again I am telling, partitions must be subset of the main set, and the partitions must be disjoint, no element should be common, and union of the partitions must equal to the main set A. Then we can say A1, A2 and A3 are partitions. Follow me? Now we can decide, or now we can frame the definitions. Okay, what is the definitions? Definitions is a partition of a set A is a set of non-empty subsets of A. Look at definition. Definition means partition of a set A is a non-empty subset of A. This term is very important. Any non-empty subset of set A can be called as a partition. So in first part of the definition we are getting, a partition of a set A is a set of non-empty subsets of A such that every element of A is in exactly one of these subsets. Look at to this point. Every element of set A is exactly in one of these subsets. माने सेट ए रो जे कोनसी एलिमेंट a1 a2 a3 भितरु जे कोनसी गोटिए रे ही रहइबो तेणु मो कंक्लूजन ड्रॉ कली दे नथिंग इज कॉमन इन बिटवीन देम एंड दे आर डिसजॉइंट्स because in definition it is given that every element of set A is present exactly in any one of these subsets. ए जे कौन एलिमेंट नौ से इधर a1 रे रहिबो और a2 रे रहिबो और a3 रे रहिबो बोथ रो कॉमन एरिया रे किछि भी रहिबो नाही and जेहेतु every element of A is present in this, so the union must equal to the set A. So again I am telling the definition. A partition of set A is a set of non-empty subsets of A such that every element of A is in exactly one of these subsets. Okay, all subsets are disjoint and when they get united they forms the original set A. In this case we say A1, A2, A3 are partitions. So conclusion are partitions do not contain any elements in common, they are disjoint sets. If all partitions of set are united, it must be equal to set A. It means all elements of set A must present in any one partition. Clear? Now look at it clearly. Here A1 and A2 are not partitions because some elements are present in it. So A1 and A2 are not partitions. Okay. Now let us take a set A is equal to 1, 2, 3 and find all of its set of partitions. How many partitions can develop from set A is equal to 1, 2, 3? So partition means what? We have to find the subsets of set A which obey these conditions. Okay. So we have to write the subsets of set A. Let this is partition 1. So in subsets of set A, can we write 5? No, because in definition of partition it is given non-empty subset of A. So we cannot take 5. So first partition what is coming? 1, 2, 3. These are subsets. 1 is a subset of set A, 2 is also subset of set A, 3 is also subset of set A. Now this set of these subsets is a partition. So this is first type of partition, also written as 1/2/3. Okay. Look at this is partition or not, it obeys the partition condition or not, so they must be disjoint. Look at these are disjoint and their union must give to set A and they must be subset. It obey all the following conditions, so that is a partition. So bit 2. Think another type of partition what is possible. One is 1, 2. This is a subset of A. Other is 3. This is also subset of A. Now this is a partition. This partition contains 3 elements. This partition contains 2 elements. One element is the set 1, 2. This is a partition, and 3. This is a partition. Look at, there is nothing common in between the partitions, and also both are subset, and uniting these two we get set A. So these are also partitions. This type of partition symbolically represented as 1, 2/3. So what are the other type of partitions? No. Partitions 1, 2 एटे 1/2 थिला ना, 1, 2 भितरे partition लिखिला बेले कमा रहबनी. Now the second another type of partition is set 2, 3 set 1. Look at, both are subset of A and nothing common, both are disjoint and union also gives A. So this is a partition. This is symbolically written as 2/3/1. Okay. Now think, is there any other partition is possible? Think. Okay. Yes, there is another partition is possible, that is 1/3 set and 2 set. Look at, both are subsets of the set A, and uniting both we can get the set A, and they are disjoint. So clearly these are also partitions. This is symbolically written as 1/3/2. Okay. Now think, is there any other partition is available? Think, is there any other partition is available? No. Yes, available. That is this set directly 1, 2, 3. The given set directly can also a subset of A. Can also a subset of A. So the set itself is a partition. Whole set that will be a partition or not? Yes. So symbolically this is written as 1, 2, 3. So if set A is equal to 1, 2, 3, these are the 5 types of partitions available. Partition लिखिला बेले ध्यान देव, जो गुड़ा को partition से गुड़ा को set A रो subset हेबा दरकार, and सेमानक भितर नथिंग कॉमन रहिबा दरकार, माने सबसेट गुड़ा को डिसजॉइंट हेबा दरकार, एंड सबसेट गुड़ा को यूनाइटेड कला बेले मेन सेट हेबा दरकार. सही कांसेप्ट रे दीज आर द पार्टीशंस. Now we will think, but now we will discuss एमिति किछि सेट्स जो गुड़ा को पार्टीशन भली फील हबो, but actually they are not partitions. Look at, I am writing another thing. Okay. 1, 2, 2, 3. Now here also 1, 2 is a subset of A, 2, 3 is a subset of A. If 1, 2 and 2, 3 undergo union, then we get the set A. So is there partitions? No. One condition fail, they must be disjoint. Partitions must be disjoint, but they are not disjoint, so this is not a partition. Similarly, 5, 1, 2, 3. But this is not a partition, because in partition empty set cannot be considered or cannot be counted as a partition. Partition definition tells that non-empty sets, non-empty subsets. So if phi is present, whatever may be present, it is not a partition. Okay. Now look at another thing. Similarly, if I will write 1, 2. Is it a partition?
No.
No. Why?
3 is absent.
Yes, because 3 is absent. If we unite them, then we cannot get set A. Okay. Very simple, students, how to write partitions of a set. So we have discussed what is the meaning of partition and how to write partitions of a set. Okay. Okay, students. Again a very interesting topic, that is binary relation induced by a partition. Every partition induces a binary relation. So remember the heading topic, binary relation induced by a partition. What is its definition? Now, any relation written as per this definition means relation set contain the order pair xy such that x and y are present in same partition. This is the binary relation induced by a partition. Okay. Remember, This is the definition of a binary relation induced by a partition. Every partition would a binary relation would develop karibo. What is that binary relation? Partition develop kariba binary relation ko ame lekhiba order pair xy such that x and y are present in same partition. Both x and y are present in same partition. So look at, recall, set A is equal to 1, 2, 3, partition 1, let us symbol P1. What is the partition 1 we have got? 1, 2, 3. This is the partition 1. Now we will find the relation induced by this partition. Let us take as R1. So relation induced by a partition will be a set containing order pair xy such that x and y are present in same partition. Here this is a partition, it contains 1, so I can write 1, 1. They must present in same partition. Now I cannot write 1, 2 because 1 is present in a partition, 2 is present in another partition, so I cannot write 1, 2, but I can write 2, 2 because they are present in the same partition. Similarly, I cannot write 2, 3, I cannot write 1, 3, but I can write 3, 3 because they are present in the same partition. बुझिपारछना पिला माने पार्टीशन रु इंड्यूस हेतिबा रिलेशन लिखिला बेले ऑर्डर पेयर गुडा को एक्स वाई भाबिबो एंड मने रखिबो बोथ एक्स एंड वाई आर प्रेजेंट इन सेम पार्टीशन. Let us take another example so that you can understand clearly. Partition 2 we have written 1, 2, 3. This is the partition 2. Now let us write the binary relation induced by this partition R2 xy such that x and y are present in same subset. Means I can write 1, 1 or not? Yes. Similarly, here I can write 1, 2 or not?
Yes.
Yes. Because here 1 and 2 are present in same partition. Also I can write 2, 1. Also I can write 2, 2. Because they are present in same partition. But I cannot write 1, 3. I cannot write 2, 3. But I can write again 3, 3. Because they are present in same partition. If partition भितर गोटे एलिमेंट अच्छी ताहले आमे केवल सेटा 1, 1, 2, 2, 3, 3 लिखि परिबा. इफ पार्टीशन भितर 2 एलिमेंट्स अच्छी ताहले आमे 4 ऑर्डर पेयर लिखि परिबा 1, 1, 1, 2, 2, 1, 2, 2. Okay. Similarly, for any partition we can write the relation induced by the partition. Let us go for partition 3. What is partition 3? Partition 3 is a set 1, 3, 2. So what is the relation induced from this partition set? Order pair xy such that they are present in same partition. So I can write 1, 1, I can write 1, 3, I can write 3, 1, I can write 3, 3. Remember here, if a partition contains 2 elements, then 4 order pairs are possible. If a partition contains 1 element, then 1 order pair is possible. So this is the binary relation induced for partition 3. Now come to partition 4. It is 2, 3, 1. This is partition 4. What is the binary relation induced by partition 4? Again same concept. Order pair xy such that they are present in same partition. So technique is, if partition contains 2 elements, then there will be 4 order pairs. What are they clearly? 2, 2, 2, 3, 3, 2, 3, 3, and here it contains 1 element, so it is 1, 1. Okay, if partition contain one element, then only one order pair is possible. If partition contain two elements, then four order pair are possible. If partition contain three elements, this is also a partition. Just now we padhili. Now, what is the binary relation induced for this partition? The binary relation for induce this partition again same style रे लिखिबा order pair xy such that both are present in same partition, means I can write 1 1, also I can write 1 2, also I can write 1 3. No, no.
Yes.
Similarly, I can write 2 1, I can write 2 2, I can write 2 3. No, no.
Yes.
Similarly, I can write 3 1, I can write 3 2, I can write 3 3. So this is the binary relation induced for fifth partition or this partition. So technique te mane rakhibo, if partition contain one element, then it will develop one order pair. If partition contain two elements, then it will develop four order pair. If partition contain three elements, then it develops nine order pair. Okay, so गोटे पार्टीशन पाई बाइनरी रिलेशन केमिति लेखा जाए आमे डिस्कशन कलु. Very interesting to note that every relation is equivalence. Look at this relation is reflexive na nahi, clearly reflexive, symmetric, transitive, equivalence. We know this relation is equivalence. Now come to relation 2. Is it reflexive or not? 1 1 2 2 3 3 present reflexive. Symmetric or not? 1 1 टा तो symmetric test pass करिवो, 2 2 तो symmetric test pass करिवो, 3 3 तो symmetric test pass करिवो. जहाँ हम बुझे ची आगुर मने पकाओ. Now 1 2 2 1 अच्छी symmetric test pass करिवो ना नहीं? Pass करिवो. So every element symmetric test pass कला ना नहीं? बुझ ना नहीं? अच्छा. Similarly transitive check करो. Transitive check कले 1 1 अच्छी मान तो ये transitive test pass करिवो. Now 1 2 को कहाँ से तो कंपेयर कराबो, 2 1 से तो कंपेयर कराबो. 1 2 को 2 1 से तो कंपेयर कले the requirement for transitive is 1 1, it is present. So 1 2 also pass transitive test. Now 1 2 can again compare with 2 2, the requirement is 1 2, it is present. So 1 2 again pass transitive test. Similarly 2 1, 2 1 can be compared with 1 1, 2 1 can be compared with 1 2. If 2 1 is compared with 1 1, the requirement is 2 1, which is present. So this is transitive. Clearly this is also equivalent. You can verify yourself. You can verify yourself. R1, R2, R3, R4, R5 all are equivalent relations. So the conclusion is, if we are writing a binary relation for a partition, then it must be equivalent. Here is also a very important point, that is, jodi pacharibo, how many equivalence relations of this set present, or any set ro how many equivalence relations are present. जदि पचारुछि ताहले कोन करिबा आमे ना फर्स्ट फाइंड करिबा हाउ मेनी पार्टीशंस आर प्रेजेंट. नंबर ऑफ इक्विवेलेंस रिलेशंस ऑफ ए सेट इज इक्वल टू नंबर ऑफ पार्टीशंस पोजेस्ड बाय द सेट. Very important thing पिला माने, number of equivalence relations possessed by a set is equal to number of partitions that can be developed from the set. एलिमेंट्स बही रे गोटे क्वेश्चन पाइबो, गोटे सेट देइछि कहिछि राइट ऑल द इक्विवेलेंस रिलेशंस दैट कैन बी ऑब्टेन्ड फॉर दिस सेट. सेटा हम केमिति करिबा, फर्स्ट ऑल पार्टीशंस फाइंड करिबा, जेतरा पार्टीशंस सेतरा इक्विवेलेंट रिलेशंस हबो. एंड हाउ टू राइट द इक्विवेलेंस रिलेशंस, फर्स्ट राइट द पार्टीशंस, देन राइट द इक्विवेलेंस रिलेशंस एज आई एक्सप्लेन्ड. ओके.